Hello, sir. Hello, sir.
Hello, Himanish. Am I audible?
You're audible.
Yeah, good
Good
morning.
morning.
Yeah, good morning. So I'm sharing my screen. Just give me 1 minute. So I have shared the screen. Screen is visible to you?
Yes, the screen is visible, sir.
Okay, just give me 1 minute. Hmm. Okay, so what we did in the last class?
Sir, we are discussing the type methods of charge conduction.
Okay, methods of charge conduction, and we have not discussed Coulomb's law and all.
We have not discussed.
Okay, methods of charging, discharging that we discussed. Okay. Okay, now you can try few questions here. Uh, Start with this question. Start with this question.
But it should attract, no, sir. We can
Okay, why? Give me the reason.
Sir, because in a neutral conductor, there will be positive and negative, no, sir. Means opposite charges gets to the one side and yeah, that will get attracted towards it. No, sir.
But there will be repulsion also. So why the resultant net is attraction? Because the opposite charges are closer to each other. So attractive force is stronger as compared to repulsive force. Can you see here?
Yes, sir, I can say.
Attractive force is stronger as compared to the repulse, right?
Yes, sir.
Okay. So if two body are attracting, can we say that both of them have equal and opposite charge? Means can we say both of them are positively charged? If two bodies are attracting, can we say both of them are positively charged?
Yes, sir, we can opposite. Yes, sir, we can say, no,
Based on the previous question, what you will say?
sir. It can no, sir. We cannot say because even
We
there
cannot
is a same charge also they are attracted.
we cannot say, right? So repulsion is the sure test of electrification. Whether the body is charged or not, that can only be checked by repulsion. If there is repulsion, then we 100% sure that both the body must be charged. But if there is attraction, we cannot say. Maybe one is charged, other is neutral, like this question, right?
Yes, sir.
Try this one.
The radius will increase, no, so generally in this case,
Yeah, radius will increase. So
because
generally, yeah,
repulsion increases, we can say.
because of the repulsion, radius will generally increase. Okay,
Sir, we
you
did
can
not
try
apply
this one.
chemistry in the last question, no, sir.
Sorry,
We did not apply the chemistry concepts, no, sir, here because
no, no,
generally,
not chemistry concept. Only surface tension and repulsive force. That's it.
yes,
Not even surface tension. Like only simple. That question is simple. No other data is given. So simply because of the repulsive force, charges will try to move away from each other, and that's why the radius will increase. Has to increase.
Sir, C is not possible, no, sir.
C is not possible. Okay. A is possible.
Yes, sir, A can, is possible.
Okay. So, okay, only you have to check Q equal to NE, right?
Yes,
N
sir.
should
Q
be
equal to
integer.
electron. Yes, sir.
N should be integer. That's it. That
Integer.
is the concept. Okay. You only have to focus on the concepts which are related to this question or the formula from where it is coming that you have to understand. Okay. Now do this. If you know any other student, like maybe your junior also, maybe class 11 or just passed class 10th, are you getting? Or is in class 10th going to write final 10th exam, you know? So please
Yes,
recommend, you know, those
yes,
students.
yes, yes.
Yeah. Do it fastly. These questions are only you can just explain what you is the concept, what you will do, and then we can move. How you will find it.
Q equals to any, you can get number.
That's it. N equal to Q by E. Q is 1 and E is
Yes, sir.
1.6
1
inverse
to
9.
6 into 10 power minus.
See the solution. So these
Yes,
type
sir.
of question, you just explain the process. No need to do it. Calculation you can do. So okay. Now this one. Quickly answer with reason.
The common power is by the one is the common power of the form class by class this is form. Due to we can say the form is we can say that it gets some charge as in the case of first question they attract with
Yeah.
respect
So you will say this is because of induction. Charges will appear on the surface, right?
to sir. It
Opposite
brings
charges will be closer, so attractive force will be stronger, repulsive will be weaker, like that.
yes, sir.
Okay, so this one,
That
1 minute.
form
Oh,
number
this is
is
not 1 minute. Okay, this one.
the instruction is being found on the piece of paper. So,
Try this.
sir, no, sir, because induced charges after again repulsion due to attraction, they will again distributed, no, sir. It will not longer long time.
Hmm. No, because the comb loses its net charge after some time. The excess charge of the column transfers to Earth through our body. So if you will, touch the comb with your hand, the charge will flow through your hand to the Earth or somewhat like that.
Generally, charge transfers from higher point to lower charge, sir, or like water flows from top to bottom again. Like
So from higher to higher, when you are saying means what is higher?
as I mean, positive charge,
No.
or
So
some
don't talk
charges
about it
related.
because don't talk about this flow because that we will talk in the next chapter. All the concepts related to flow. This is statics, electrostatics. You know.
Sir, attraction.
Statics means no flow, so we will not talk about how it flows or it flows. So yes, it flows from higher potential to lower potential, but before that you have to understand what is potential, what is the meaning of higher, lower. Okay. So all this we'll discuss in the next chapter. Do this. Try
It's
this.
not possible now to attract same charge.
So it is possible. It is possible. When you say not possible, so you have to think about all the possibility, all the possibility.
So
So
generally,
the,
if
so
we
the generally means it is not about generally. Is it about any case is possible?
sir,
All the possibility theoretical.
sir, either we take it any case, if two bodies are similarly charged means
Yes,
if they
they
are
will attract.
positively charged
They will
means
attract. They can attract. So how they can attract? So because of induction. So if one body is suppose very big and another body is very, very, very small, there is one very small sphere and there is a very large sphere. So then here also induction will work. You know, one body have suppose 100 coulomb charge and one body have 1 microcoulomb positive charge. One body, are you getting? Too much charge. So a strong electric field is there. Now in that electric field, read this, you'll get some idea.
Yes, so because of due to that magnitude, higher the attraction will be more. We can say, no, sir, between
Yeah,
positive and
attraction, yeah. So will be more because of that the charge redistribution will take place. Attraction between the induced charges will be more as compared to repulsion. So think about all the possibilities. Think about why the exam is asking this easy question. Think about it. They will never ask such questions. They are, if they ask that, Anna, can two similarly charged, similarly point charge, Anna, if they write point charge, then they will always repel. But they are saying bodies. Now it is totally different. Now two electrons can never attract, or two protons can never attract, because induction will not take place on point charges. They don't have any size, zero size, you can say, like negligible. But whenever body will come, now induction is possible if one charge is very large amount of charge, so its electric field will dominate. Now in the electric field of the bigger charge there is a smaller sphere. In that smaller sphere, on that smaller sphere there is some positive charge. What does it mean? It means that there is electron and proton, but electron number is little less, but there is electron. All the electrons will move closer, and because of separation, attractive force will dominate. Means this, there is a possibility of this type of arrangement. Only have to think about the possibility.
yes, sir.
There is also a possibility they will not. Means, but then you have to think whether possibility is there. Okay, try this one.
We can't say, no, sir. Depending upon the sizes of bodies, we need to say, no,
A
sir.
positively charged body attracts a body B, then charge on body B may be.
Depending upon the
Maybe
sizes.
maybe positive, maybe negative, maybe zero. All possible, right? So we'll say can't say. If it is a single character, we'll say can't say. Okay. Okay. Now this one. Do it fast. These are very easy, basic, zero level questions. Do it fast. Question is visible to you?
The question is not visible, sir.
Not visible. Now is it visible to you? Some background noise is coming.
So from my side.
Is
Now
it
it is
visible
visible,
now?
sir. So no, sir. Last question only I can see, sir.
No, this is okay. This one. Visible? Visible, not visible? Hello.
So now I can see, sir. Now I can see, sir.
Okay. Try this. Tell me what to do now.
So it acquires positive means you can say electrons are losing, we can say no, that's the only possible case.
Tell me the option.
Electrons, a day, no, sorry, you can say.
D option. D option.
It's a D set, Delhi.
Hmm. Correct. Okay, now this one. You can just explain what you will do.
1 gram of
Am I audible now?
so you're audible, sir. Man.
Okay.
1 gram of a solid color, 5 grams of chromosomes. If 1 electron is removed from every, there is 1% of the solid. Then the charge given by the solid is. So option A, sir, it will be correct.
So process what you did.
So first of all, the total number of electrons removed, I'm finding, sir.
Okay. So how you found the total number of electrons removed?
So since 0.01% of removed, no, sir, the total number
Hmm.
of electrons will be removed will be
Okay.
0.01 by 100 into.
Okay. Then you multiplied with the charge of electron, right?
Yes, sir.
Okay. Okay, so now we are going to talk about the Coulomb's law. As you already know, that Coulomb's law gives the force between electrostatic force between the two charges, and this law states that on the basis of experiments done, this law was found, and the law states that the magnitude of electrostatic force between two point charges is directly proportional to the product of the charges. So the magnitude of force is directly proportional to product of the charges, and it is also inversely proportional to a square of distance between the charges. So inversely proportional to a square of distance between the charges. What does it mean? That if the product of charges will be more, the force will be more. So for example, if product of charges is doubled, force between them will also get doubled, but keeping r constant. If suppose ru will vary, keeping product of charges constant, then f is inversely proportional to r square. So if you will triple r, the force will become 1/9, means inversely proportional to 3 square, means 1/9 of the original force it will become. If you combine both, you get the formula this. So it is proportional to product of charges, inversely proportional to square of separation between them. If you remove the proportionality, proportionality constant will come,
Sir, uh,
which is k here. So k is a proportionality constant here for a given pair of for a given medium. So k actually depends on the medium in which the charges are present. Yeah, tell me.
but how he came to? So then he said that here, first he kept the charge constant, then he observed it inversely proportional to square of distance between them. Also.
Yeah. So
That
when you
actually
are
how he found it, sir, means how he can say that it is exactly inversely proportional to square of the distance between them. So,
so that is by some experiments only, by measuring the force, by keeping at this distance and then keeping at that distance,
yes.
we can see what is the variation. So this is experimental, like, so he determined the repulsive force between the charged balls. That experiment is generally not given, but charged balls, metallic balls, they took charged balls and then measured. So there is an arrangement by which they did all this, and then he, keeping the charge constant, he measured as a function of separation. So if they increase or decrease the separation, they measured the forces. And then by analyzing all the data, he realized that okay, with the force, this is the variation. With the charge, this is the variation. It depends on product of charges and not on individual charges. So by doing a lot of experiments, it is all based on the experiment. That experiment is generally not given in the textbooks. So this law was actually first published in French. He was a French physicist. How he did that measurement, that is exactly not given. But in some book, I saw that they did some experiment using charged balls, and again there was so this is based on experiments. Also, Much detail is not given about it. So that's it. The important thing here you have to understand is that that force depends on three things: product of charges, separation between the charges, and the medium. Because the k is not a universal constant here. K is a medium dependent. K is 1 by 4 pi epsilon, where epsilon is the permittivity of the medium. Now, the important thing here is it is only applicable to point masses. So, if there is a charged rod and a point mass, you cannot use this law directly. This is only applicable for 2 point masses. Both the mass must be point mass, and they should be at rest also. That's why electrostatics. So, I'm not saying that when they will move, it will not act, but then some other forces will also act. So,
Sir, it also depends on the medium also, no, sir?
yes, because k depends on the medium. So k is 1 by 4 pi epsilon, already explained. And epsilon is the permittivity of the medium. Okay, so for different medium, now here you have to understand that epsilon is the permittivity of the medium, and it is given by epsilon r into epsilon naught, where epsilon naught is the permittivity of the vacuum. So permittivity of any medium is given by this formula. Now here you have to understand that this epsilon r is called as a relative permittivity of the medium.
Sir, what
And
is general permittivity, sir?
relative permittivity. Epsilon r is the relative permittivity of the medium, and it is also called as dielectric constant. So this is another name of dielectric constant. Epsilon r is relative permittivity of the medium, and it is also called as dielectric constant. Now, for vacuum, epsilon will be epsilon naught, epsilon r relative permittivity for vacuum will be 1, and this is the value of the 1 by k in vacuum, 1 by 4 pi epsilon naught. So epsilon naught, which is the permittivity for vacuum.
Sir, generally, what is the permittivity, sir? Hello, sir.
Yeah. So permittivity, you can say that it is the ability of the medium. Actually, you can say that measure how much the electric field will polarize a medium,
So, how the, I mean, first,
how much electric field will polarize any medium,
sir,
or you can
polarize.
say, or you can say that how much a given substance or a medium permits the electric field lines to pass through it. Actually, different medium, have different permittivity, and you can say all the mediums do not allow the electric field lines to pass through it in the same way. So basically, there are two things. One is permittivity, one is permeability. Permittivity is related to electric field lines, and permeability is related to magnetic field lines. You can say that permittivity is a property of the medium which actually indicates or measures the opposition offered against the formation of electric field. So if a charge is placed in a medium, electric field intensity around the charge will depend on the medium. So in some medium, the electric field intensity will be high. But if the same charge is placed in another medium, then at the same distance, electric field intensity will be low. So different medium do not allow the formation of electric field. So how much it opposes to the formation of electric field around the charge, that is, you can say, is the permittivity of the medium. Means there will be some mediums which will allow the formation of electric field intensity. So electric field intensity will be more in that medium. Whereas there is another medium in which if you place the same charge, then at the same distance, you will see that the electric field intensity will be less. So somewhat it depends on the medium. How much the medium allows the formation of electric field, that you can say is the permittivity. So there are different ways it is defined, but ultimately you have to understand that, you know, so how much electric field intensity will be there because of a charge, that depends on the medium and the property of the medium which is opposing the formation of electric field, that you can call as permittivity. So for example, if there is a vacuum, then the permittivity is, you can say, is very high. Means permittivity is, you can say that, means it will, there will be low opposition, means highest electric field will be there in the vacuum, because there is nothing to oppose. Vacuum means what? Nothing is there. Nothing is there to oppose the formation of electric field. But if the same charge you place in another medium, then the medium opposes the formation of electric field. And how medium opposes? So because of the charge, the medium also gets polarized. So it is related to polarization of the medium. And different medium gets polarized in different way, and that's why to different extent they will oppose the formation of electric field. That's why different medium has different permittivity. Are you getting some idea?
So means how much it is opposing the uh, electric flow. I mean,
You can say formation of the electric field or the flow of electric field, any word you can use. Yeah, means there is a charge. Electric field is, whenever charge is there, electric field is there. Now, how we measure electric field? When I say electric field is there, electric field is just a region, right?
yes,
In
yes.
that region, any other charge will enter, that charge will experience force. But then how you will compare the electric field, and you will say that this is a stronger electric field, this is weaker electric field. So in electric field, every point has a potential that we will discuss in the next chapter. And at every point, there is electric field intensity. So electric field, है ना, magnitude wise, if we talk, then the quantity is, electric field is not a quantity, first of all, because it is a region. Electric field intensity is a quantity. So you can simply say that because of charge, there will be electric field in any medium, but the intensity of electric field That depends on the medium. So there are, and that depends on medium when I say. So then that depends on the, so the property of medium which decides what will be the electric field intensity due to this charge. That property you can say is you can say means you can say is permittivity. So it depends on permittivity. Now what is permittivity? So permittivity is that property of the medium which opposes the formation of electric field. Why we say opposes the formation of electric field? Because if permittivity will be more, then electric field will be less, intensity will be less. That's why we say opposes, because inverse lessons. Are you getting? So it is defined in such a way.
Sir, what is the quantity? The opposing means it's a value or something, sir. How we
What?
are measuring that value, sir?
Which value?
Permittivity only, sir.
Yeah. So permittivity value is very simple. Permittivity value is like you will place two charges in vacuum and then you will place the two same charges in medium, and then what is done that they measure the force between the charges in the medium, force between the charges in the medium, and then divide by force between the same two charges in the vacuum. So, no, 1 minute, not like this, not correct. So, force in, you can say in force in vacuum by force in medium, force in medium, and that is you can say epsilon, epsilon of the medium. No, 1 minute. That is not epsilon. That is epsilon r, relative permittivity of the medium. So relative permittivity simply tells you that how many times the force will be reduced if the charges are placed in that particular medium. For example, if relative permittivity of a medium is suppose 7, what does it mean? That the force between the charges will be 7 times weaker in that medium as compared to the force in vacuum. So this is how epsilon r is measured. And you only have to measure the relative permittivity, because you got the relative permittivity, then you got permittivity. Because permittivity is nothing but relative permittivity times the permittivity of vacuum. So the only way to measure the values of permittivity is by measuring the forces. Actually, you will see that in other system of units, you know, the permittivity value is simply taken as 1. In CGS unit, permittivity is 1 and K is 1 by 4 pi only, because epsilon naught is 1. So you can say that vacuum is taken as a reference And then with reference to the vacuum, you can say other medium forces are compared, and then epsilon r is decided. So clearly much text is not available actually, that how exactly that is measured, but these are the things that you have to understand. So permittivity, you can say permittivity is just a reference is taken, because in CGS unit its value is just 1. CGS unit. That's why the relative permittivity is important, because different medium has different relative permittivity. For vacuum, in CGS unit, its permittivity is taken as 1, and its relative permittivity is also 1. For different medium, different relative permittivity. So this value is in SI unit, but its value in CGS unit is 1. So I think a reference is taken simply that vacuum, whatever is the value, will start with 1, and then so actually the meaning of permittivity is also with respect to the vacuum, and that is decided based on the force, like with respect to the force between the charges in vacuum, how much stronger or weaker is the force in that medium, that decides the relative permittivity, or you can say permittivity, taking vacuum as the reference, permittivity of vacuum as the reference. Permittivity of vacuum is taken as 1 in CGS unit. Epsilon naught is 1. In CGS unit, K is simply 1 by 4 pi. But generally, we don't use that. We use SI. So that's why the value comes out to be this. Okay. You can ask your doubt.
Yeah, understood.
Okay. If I'll get some more idea about this, we'll discuss again. Okay. So the next important thing is that this force is a central force, and this force again acts along the line joining the two charges. Next is that the electrostatic force again is a conservative force, because the work done by the electrostatic force only depends on the initial final position, does not depend on path. This we will prove in next chapter, because to prove this the concept of potential is required, and then we will prove this is that's how it is conservative. Now since the force is a central force, in absence of any external force, the angular momentum of one particle with respect to the other is conserved. So you know that in case of central force, always angular momentum of the system remains conserved. Angular momentum cannot change, because the central force cannot produce any torque. Net external torque due to the central force is 0, and that's why the angular momentum is conserved. Now the next is vector form of Coulomb's law. So in the vector form, Coulomb's law is expressed in this way. Now you already know that force is a vector, Charges are scalar. Okay. So this is the magnitude of the force. This is the magnitude actually, which we already discussed. Now we only have to attach the direction. Direction, how we attach direction? We attach by attaching a unit vector. So this r cap actually denotes the unit vector in the direction of the force. And you already know that if there, suppose this is y axis and this is x axis, and there are two charges placed. So suppose two charges are placed like this. So here one charge is placed, here another charge is placed. For simplicity, we are just taking both as positive, but you can take anything, that does not matter. You can take both positive, both negative, any positive, any negative. But now, what I am trying to calculate is the force on 2 by 1. Force on 2 by 1. So this is position vector of the second charge, and this is position vector of the first charge. You can call one as r1 vector, and you can call second as r2 vector. And now you know that the force on 2 by 1, you already know what will be the direction, because direction is decided based on their sign. So both are similar. So the force on 2 by 1 will be in this direction. Now we'll have to give this force some name. So because this is force on to, so first you will write here 2, and it is by 1, so 1. So F21, this is the direction of the force. Now in the direction of the force, and how you will express this direction. To express this direction, you know that the direction is always along the line joining the two charges. That's why first we will define this as a vector which is along the line joining. So line joining q1 to q2. Let's define one vector joining q1 to q2. And let's call this vector as, you can call anything, that does not matter. But you call it anything. You call it R21, R12, R or anything. It will always be a vector joining 1 to 2. Does not depend on what you call it. Some books call it R12, and that is correct because it is joining 1 to 2. So now you can clearly see that the direction of F21 vector is in the direction of R21. That's it. Now you can express it in terms of this R12 vector. So F21, if you have to represent it in vector form, you will simply represent its magnitude, which we already know. So that's why I'm not writing, because it will be k q1 q2 by r12 magnitude square. So I'm simply writing as F21, and then we'll attach a unit vector in the direction of r12. Now unit vector, how we represent? So vector by magnitude. So r12 vector divided by magnitude of r12. Now tell me, any doubt you have, you can ask.
That means depending on the direction, you should take the R12 or R21 also.
Yeah, so depending on that, you will take R12 or R21. But the important thing is you understanding that what does R12 represent and what does R21. So R12 represents a vector joining drawn from Q1 charge to Q2 charge. You can ask your doubt. If it is force on 1 by 2, then no need to do anything. Force on 1, if you have to do by 2, no need to use R12 or R21. Force on 1 by 2, it is same as this. Only put a minus sign there. Are you getting?
Yes, yes, yes.
Sense.
That's it. Because you know now from vector that this vector R12 is a negative vector of R21. How we know it is a negative vector? From Newton's third law, we know that it is a negative vector. because equal magnitude opposite direction is called as negative vector. Are you getting? Now equal magnitude opposite direction comes from Newton's third law, action reaction pair. That's why we are putting a negative sign. Now you can ask your doubt in this topic.
No doubt, man.
Hmm. Okay. Now the next is, so once you understood the vector form of Coulomb's law, now there is a principle called as principle of superposition. Principle of superposition simply says that the electrostatic force between two charges, listen carefully. Principle of superposition simply says that the electrostatic force between two charges is independent of the presence of any other charge. So two charges are there, force between them will be F. And near those two charges, if you bring any other charge, still the force between the first two charge will be F. So that does not depend on presence of any other charges. Indirectly, what does it mean? That all the charges which will exert force on this Q charge, their force will be independent of the presence of the other. If that is the case, then it simply means that all the charges are exerting their own force, and that does not matter which other charges, how much force other charge is exerting. So every charge is exerting some individual force on this particular charge here, which is taken as Q here. So all Q1, Q2, Q3, Q4, they are exerting their own force. And their own force is not changing by due to the presence of the other charge. Because all the force between any two charges is independent of the presence of other charge. Other charge is there or not there. Force between any two is same all the time. That's why to find the net force or resultant force on a particular charge, you can simply add all the individual forces. Everything in the nature do not follow principle of superposition. Means there are quantity which changes due to presence of other things around it, but not the electrostatic force. So electrostatic force here follows the principle of superposition, and if you have to find net force on a particular charge, you will simply add all the individual forces that all the other charges are exerting on that particular charge, and then you will add them. When I say you will add them, the addition will be vector addition because they are vectors. That's it. It is very simple thing. You can ask your doubt.
So no doubts, man.
Okay. So, and once you understood this principle, now a lot of questions will come. So, using principle of superposition, you can find the forces. So now you can quickly just explain how you will find this. Then we can go to the other question. Do it fast.
So one-edged one will be no, sir, but opposite in a sign.
So what is
One,
the concept here?
sir, columns. Can I put it a formula now, sir?
You will say when I ask what is the concept, you will say Newton's third law.
Nice, Newton's focus.
Is there anything other than Newton's third law?
So no, so only
If
Newton's
you
first
don't
one.
know Newton's third law, can you answer this question? If you don't know Newton's third law,
We cannot answer.
okay. So now you can still answer about the because at the formula of the Coulomb's law, whether the force is on Q1 by Q2 or on Q2 by Q1, the formula is same, no? K Q1
Yes,
Q2, product of charge. And you also know the direction with the sign that from sign you can find whether it is attractive or repulsive. But yeah, the fundamental thing is Newton's third law. It follows Newton's third law. All the forces generally follow Newton's third law. Okay, now try this.